I'm just going to go through the homework that I set, the Springs and Hooke's law, conservation of energy. As a reminder, F equals KE, so force equals spring constant times extension, and elastic potential energy is a half times K times E squared. I've got a previous video that goes through where these equations come from, so please feel free to watch that first. Question 1. All the way through this and all the way through your physics career, you'll need to be thinking very carefully about units and the units that are expected in the answer. As a general rule of thumb, force always newtons, spring constant newtons per metre, extension in metres, and elastic potential energy. It's a type of energy, so definitely joules. So we've got 2 centimetres, so the spring is stretched, so E for extension is 2 centimetres, and the mass is 40 grams. So we're trying to find the spring constant, K. First things first, let's go through what we've got and see if we need to do any substitutions. So 2 centimetres, we need to convert that into metres. So that's 0.02 metres. Grams, well that's 0.04 kilograms, but that isn't in newtons just yet. So it's well worth remembering another equation. Weight is mass times gravity. For argument's sake and ease for today, I'm going to assume gravity is 10, although really it should be 9.8 newtons per kilogram, but we'll use 10 just to make the calculations slightly easier. There's our mass that we have got over here, and then weight is a type of force, so we can multiply by 10 to get it into newtons. So our force is 0.04 kilograms times by 10, so 0.4 newtons. We're trying to find the spring constant, so we're going to need to rearrange for K. F over E, that's 0.4 divided by 0.02. Which gives us an answer of 20 newtons per kilogram. For question 2, let's look at the key things. So we've got K, which is 3430, and we're trying to find how far, so the extension, when we have a 70 kilogram person. So we know K equals 3430 newtons per metre. We know the extension is what we want to try and find out. And we know the mass is 70 kilograms. So the first thing to do, like we did before, is multiply the mass by gravity. So again, we'll use 10 for argument's sake. So the force then becomes 700 newtons. We use our equation and rearrange it. So extension is force over spring constant, 700 divided by 3430. And this works out to be about 20 centimetres, 0.2 metres. For question 3, a force of 200 newtons stretches a spring 30 centimetres, so again need to convert 0.3 metres. What is the spring constant? So that's K question mark. And the second bit is how far will it stretch? We'll worry about the first bit first. Again, let's remind ourselves of the equation. F equals KE. So K equals F divided by E. which is 200 divided by 0.3, which is roughly 670 newtons per metre. So now for part B, how far would it stretch if we had a force of 100 newtons? So another force, we now know K from the previous question. We want to find E. So that's F over K, so 100 over 666.7, which is 0.15 metres. Now, is that what we expect? Well, yes it is. We've halved the force, so we've halved the extension. So that looks about right. For question 4, 20 kilogram box, we need to convert that into newtons, so it's 200 newtons multiplied by 9.8 or 10, and the spring constant is 300. The box is resting on a frictionless surface and the spring is compressed by 30 centimetres. So 0.3 metres. What is the EPE of the spring? Okay, so our equation for EPE is a half KE squared. You get given that equation, you do not need to memorise it, but you do need to rearrange it. So we're trying to find the energy, so it's 0.5 multiplied by 300 multiplied by 0.3 squared. As a reminder, you just square the 0.3, so this equation 0.5 times 300 times by 0.09, so that's 0.3 squared. Plug all that into a calculator, the amount of energy in joules is 13.5. The question then says, what will the kinetic energy of the box be when it springs back? Well, we can assume, because of the conservation of energy, that if you start with this much energy, you will then turn it, the spring will then turn it all into kinetic energy, so it's the same answer as before. And then how fast will the box be moving? Well, for this one, we need to remember the kinetic energy equation. And as a reminder, that's a half mv squared. We're trying to find v, the speed. So we need to rearrange the equation. So that's 2ke equals m v squared, multiplied both sides by 2 to remove the half. We then can do 2ke over m, and that leaves velocity squared. And then the final step, if we square root both sides, we're left with v. So the answer for this one is 2 times 13.5 from before, divided by the mass. Well, the mass from the question is 20 kilograms. Put that into the calculator, press equals, then square root it all, and the final speed is 1.16 meters per second. For question 5, spring has a spring constant of 256, so K 256 newtons per meter. How far, so that's the extension we're trying to find, must it be stretched to give an elastic potential energy of 48 joules? So again, let's remember to look for the right equation. You get given it a half KE squared. Some people like to put the numbers in first and rearrange. Other people like to rearrange first. Doesn't matter, I'll go through both methods. So we know 48 equals 0.5 times 256 times E squared. So 48 equals 128 times E squared. So 48 over 128 equals E squared. So 0.375 equals E squared. So to get E by itself, you have to square root it. So E equals 0.375 square rooted, which gives an extension of 0.6 meters. The other method is to put the numbers into the equation after you've rearranged it. So 2 EPE, remembering that's one thing, divided by K square rooted equals E. So that's 2 times 48 divided by 256. Press equals and then do the square root at the end. And by all means check it for yourself, but you get the same answer. So it doesn't matter which method you prefer, it's up to you. For question 6, we've got a spring constant of 35, and we want to find how much it needs to be compressed to store 1.5 joules of energy. So EPE equals a half K E squared, and like the last one, you can put the numbers in first or rearrange it first. 2 EPE over K square rooted is going to give us E. So 2 times 1.5 over 35 square rooted equals 0.29 meters. And if you prefer putting the numbers in, pause the video and work through what I've done just there. The final question, we've got a spring constant of 25,000 newtons per metre. So that's a very stiff spring, and just as well because it's in a car. The bigger the spring constant value, the stiffer the spring. How much is each spring compressed if it supports 1/4 of the car's 12,000 newton weight? Right, so each spring is that, but this is the total weight, and there's 4 springs. So the first thing to do is work out the weight on each of the springs. So if my maths doesn't fail me, each spring will have 3,000 newtons of weight. So that's our force. So we're after how much it's compressed. Well, the thing is with Hooke's law, it works for extension, but it can also be compression as well. So E is just how much the spring changes shape, how much it extends by or how much it compresses by. So you can have a spring that's wide, and if you apply a force to it, it of course will compress. So you're measuring how much the difference is rather than the extensions. That's the compression. So in this case, we're trying to find the compression. So that's the equivalent of E, the extension. So extension is force over the stiffness. So each one is 3,000, and the spring constant is the same for all of the springs. So 3,000 divided by 25,000 gives us an extension of 0.12 meters. So 12 centimeters. I hope you enjoyed the video. Any questions, as ever, please ask.